that isn't pressure, I don't know what is. Hugely
Welcome.
useful. Hopefully you will find this hugely useful. My name is Mike Gehard. I work at Pivotal. We have an office here in London. I'm going to put in the proverbial, if you're looking for a job, please come talk to me. London is blowing up. The new office is beautiful. They need a lot of people to fill it, so come chat with me. So, journey from monolith to microservices. The goal of this talk is to kind of break up some of the marketing hype that sits around microservices these days. So we'll see how well I do. So a little bit about me. I, up until 3 weeks ago, was a consultant at labs. I have now become a lead developer, so this conference is perfect for me. I'm struggling with all of the things that we mentioned earlier. I also worked on the Spring Cloud Services team. So this is a team inside of Pivotal that builds tools using the Netflix tools to allow microservices very easily in Spring Boot and Java. So if you're a Spring Boot Java developer and you have questions, please come see me. I am also trying not to be the chief principal senior consultant scientist. I got that from Russ Miles at another conference in Stockholm. My goal here is to not sell you on microservices, not to sell you on monoliths. It is to give you information about what I think a path might look like, and tell you why I think that, and tell you the constraints that I worked in to get to that path, such that you can make your own decisions as to whether or not you want to follow the path. And I'm constantly forgetting to advance my slides to make the color go, so we'll see how this goes. So about you, how many people have a monolith that needs migrating? Yeah, come on. Really? All right, that's good. Keep your hands up. How many of you are actively migrating that monolith? Okay, keep your hands up, please. How many people are building microservices right now? What are the rest of y'all doing? I thought this was like the greatest thing. Like this was it. This is all we do as software developers. So that's good. So hopefully you'll get something away from this. So I'm going to tell you a little bit of background, where this idea came from. None of this is new. So if you're sitting in your about halfway through the talk and you're like, yeah, this all makes sense. I was doing this 10, 15 years ago. You are absolutely correct. Unfortunately, we have forgotten some of this, so that's why I continually like to remind people. We'll talk about which comes first. So whole monolith versus microservices discussion. I will give you my opinions. You can take them or leave them. And then we'll talk about the path. Like I said, this is one path that I think will work. There are many, many other paths. It really just depends. So this idea, while not new, was kind of formalized by this guy named Mike Beranek. He works at Pivotal as well. He was our office director in Boulder for a very long time. He came up with this idea of the App Continuum. So if I'm writing Sinatra and I have 300 lines of code, I really don't have to do a lot with that. There's really not a whole lot I can do with that. So I can start here at this end, very unstructured. As my app grows, I can move into namespaces, libraries, applications with libraries, or services. So this is a continuum. This is not thou shalt pick monolith or thou shalt pick microservices. You might end up right here as the start of an app. And I'll kind of explain why. About 6 months ago, I found Mr. Simon Brown. Does anybody know Simon? Will you please tell him that I think he's brilliant? He has this idea of well-defined in-process components as a stepping stone to out-of-process components. So Dan and I were just talking about this whole idea. If you can't build a well-structured monolith, what makes you think you can build a well-structured distributed system full of microservices? And I love this idea because it gives me room to make mistakes early on, and then once I can then move along and do the hard stuff. So what better way to try this is on a client project. Yeah, this is fun. So we had a big client in Colorado, think cable communications company. What's so funny?
Very sneaky.
Oh, okay. So big company, getting ready, like everybody else, to be disrupted by some Silicon Valley company. This one just happened to be Netflix and Hulu. They came to us and like, hey, we've got this thing. It's working, but it's not the future. So they had to migrate a monolith. It was a big Rails app, unfortunately. Production, making money to a more sustainable solution for the future. They knew they needed scalability. So Netflix, Hulu have proven the fact that as you get more users, you are going to become very, very popular, and your app needs to not fall over when the NBA finals run or the NCAA finals run. So they knew this. This was not a guess. They knew this. They wanted multiple teams to be able to deliver business value quickly. That's almost a given. Like, who doesn't want multiple teams to deliver business value quickly? And they wanted to be able to add and reduce resources pretty quickly. So this means getting someone ramped up very quickly. They might work for a couple of months and then have to go somewhere else. So this was their goal. Their current state, as you can imagine, a set of API servers, multiple clients, including JavaScript. So think Xbox, set-top boxes, web front end, mobile devices, lots and lots of the things. This was a fun one. Sat in a meeting one day, I was like, what does this code look like? How much is you're using? They had inherited some of this code. They're like, well, we know it's between 0 and 100. I knew it wasn't 100 because the app actually ran, and they were making money. But we didn't know how much dead code there was. So this is dangerous. If I don't know how much dead code there is, I don't know what I'm using. Coupled with the fact that they had a lack of comprehensive current API tests, makes that a super dangerous situation to live with. Why does it make it such a super dangerous situation to live with? Anybody? All right, we'll keep going. If I take dead code out and no tests fail, I assume that code is not needed until someone calls up and says their player doesn't work anymore. So this was really scary to us. We're like, okay, sweet, that doesn't make us happy. So we decided to move along. And this is my favorite, I'll go out and say, quote of all time as an engineer. So I have 2 engineering degrees. I have a bachelor's in chemical engineering and a master's in software engineering. So as an engineer, tried and true, I love this. Because as an engineer, I know it always depends, which is why the huge caveat up front of telling you, this is my story and my journey. It may or may not resonate with you. So there is a drinking game that goes along with this talk. Every time I say it depends, you should drink. If you're drinking coffee, you might be a little jittery at the end of this talk. If you're drinking water, it's okay to head out to the bathroom. So which comes first? That's the thing. We can go monolith to microservices. We can start with microservices. You ask 6 people on Twitter, you will get 7 different answers from said people. I am personally leaning towards well-structured monoliths first. I do not trust myself to get the bounded contexts right for my application to build microservices first. That said, if you are building a banking app and the app hasn't changed in 15 years, and you don't foresee it changing for the next 15 years, your bounded contexts are probably pretty okay. Does everybody know when I say bounded context that I'm talking about? Eric Evans' The Blue Book, which is great nighttime reading if you have trouble sleeping. There's another book. It's a red book. I enjoy that better because he actually moves bounded context to the beginning of the book, which I feel is the most important piece of the book. Unfortunately, Eric, when he wrote his book, put it at the end. So you're kind of like getting to the back, you're like, not important. So these bounded contexts are what we're doing with our microservices. Anybody done SOA, service-oriented architecture? Yeah, you're like, well, this is just SOA. I'm like, yes, exactly, with bounded context. That was the mistake we made with SOA, is we didn't have bounded contexts. We'd put all the logic in the bus, and now we had tight coupling in the bus, and nobody knew where the logic was. So this is why I start with a monolith, is I can play with the bounded contexts first before I get distributed systems problems. So the path. Anyone make a guess of what step 1 on the path is? No. Nice try, though. How many people know Pivotal? What do we do first? We write tests. So this analogy of rebuilding this is like flying an airplane. So this airplane's flying along. It's not doing so well. You need to build another one. So you have 2 options. You can land the airplane, build the next one, move everybody over, and take the second plane off. Or you can fly another littler plane up to the first one and start. So we built some API level tests. So I'm talking big black box, hit from the outside, don't get to touch the database internally at all type tests. And we wanted to make sure we didn't break any client-facing behavior. That was our goal, because this thing's in production. The airplane's flying. We don't want to drop somebody 30,000 feet to the ground. That's bad news. So if this is what your app looks like now, we want to go to this. This is our end state for the refactoring. Why not write your test that way? It's just going to hit all the same endpoints. The nice thing with these, if we decide to gut the application and rewrite it in a new language, we can still leverage these tests to tell us whether or not the thing still flies. Any other level of test, I believe, is waste because they may or may not be reality at this point. Unit tests, those all go out the window because we're going to change what this thing looks like. We use Pact. Any thought workers? Cool. It was interesting. We had a little trouble with the JavaScript client, but it was really cool because we can now define contracts between the clients, the consumers of the APIs, and the producers. And the whole idea being, if I have a contract, what's the first thing you do when you test a JavaScript application? You write some little server that just serves up dummy JSON. And on the other side, when you write the back end, you write a bunch of tests that say, when I hand you this JSON, you're going to hand me this JSON back. The cool thing about Pact is you write the contract in JSON, it will generate both sides of that for you, so you can now run all of that in both test suites to assert that you haven't broken the contract. Because that's the danger of stubbing things out, is if the contract shifts a little bit, now you're dropping people 30,000 feet to their death. So we use these to shore up the contracts between the client and the server so that we could run them in both test suites. So now that we had these in place, we know when we've broken something, and we know it very early. We get these fast feedback loops. We're not waiting to go to production, have the NBA finals start, and then someone complains they can't run the Xbox client or something like that, or some ancient version of the client application. So step number 2, you want to arrange your application so you can see your domain. Everybody know who Uncle Bob Martin is? Seen his talk, Architecture of the Lost Years? This is where this comes from. So if you look at this picture, what can you tell me about this application? It's a Ruby application. It's probably Rails because I have models, views, and controllers. Can you very quickly, at the glance, tell me what the domain is of this application? Not very easily. What about this one? This happens to be Java Spring, but you could do the same thing in Rails. You can say it's a web application. The web application is separate from the domain, and it deals with orders and users very quickly. If I need to change something in orders, the orders domain, what is the maximum number of directories I have to go into to make that change? 3. In this application, what is the maximum number of directories? 1, maybe 2 if I've got to go up higher into the web application because I've got API changes. So this is what I mean by organizing your application so you can see the domain. Granted, in Java, I've got this hierarchy of folders, but you can ignore that. So the first thing it does, it minimizes the number of directories I have to change or go into change. It's less costly to evolve bounded context and experiments with boundaries because I'm just shuffling files around in a Git directory. I'm not having to go talk to another team and say, hey, I want to move this file into your system. Will you move it, heaven forbid, into your completely separate Git repository? I'm a big mono repository fan. We can discuss that offline. But I can just shuffle these things around for a while. If I don't know what they look like, it's a low cost of entry. I'm also delaying architecture decisions. Always delay the architecture decisions to the last responsible moment. And you can just sit here and just iterate on your software. So if you're an early stage startup, you want to be spending money on doing your startup stuff, not architecting software. If you're a large bank, you might already know what that looks like, so you might not want to do this. It really just depends. The third step is to break out some components. So I've already given myself a little bit of room by giving myself directories. I can now start to put maybe multiple teams or multiple developers into a bounded context. They can begin to understand that. There's not this explosion of where I have to go to find things. But now I want to solidify those. Because when I get to microservices, it's like having a brick wall between my applications. I'm just going to start to move in that direction. I had rice paper when they were in the same app. I'm now moving closer and closer to something like drywall between my bounded contexts. So here, Java application. I have a controller and an application. This is my layer. I then have a bunch of unbuilt jar files that contain my components. I choose to use these things called use case objects. They're simply method objects. They are verb named, and they have one method called run. That's now my external API to my web application. And you can have multiples of these. The kicker becomes databases. Where does the database stuff live? Does it live in the application? Does it live in the components? This is where I get really hand-wavy. It really depends. The one rule I have is that my migrations only can touch one table. Why do I make that the hard and fast rule in these code bases? Winner. So I can later separate the databases without having to go into a file and like split up files. I can later start moving things around. So yes, they only can touch one table. So what have I done? I've made more room in my code bases. So you'll notice a pattern. This pattern has a set of costs, and I have a set of benefits. As long as the costs are not greater than the benefits, then I'm okay to move on to the next step. But if my costs are higher than the benefits I'm gaining from moving to the next step, I might want to think twice about moving to the next step. So I make more room in the code bases for multiple teams. They just own that jar file, just iterate away. The boundaries are getting a little more solid. This is a really cool one that Rails, I believe, has floundered on for a while. And I bash Rails a little bit, but there are other frameworks. Java, you've seen Java apps that do this too. I have now a stricter boundary between my domain, which is the important stuff, and my framework. So if I decide to scrap Spring and go to play on this application, are the bounded contexts ever affected by that change? Nope. If I do a good job of keeping my framework over here and my bounded context over here, I can change the applications without changing the bounded contexts, as long as the APIs don't change. I'm moving closer to microservices without the overhead of microservices. So this is where Simon Brown takes it to the next level. He will actually say, in an application like this, the only public interface that I would have are my use cases. Nobody from the outside world actually knows whether or not I'm using Mongo or MySQL or anything like that, which sounds a lot like microservices, except they're running on another machine. And you get a lot of benefits from stopping here without the overhead of microservices. Because as people will fail to tell you when they sell you on microservices, they're huge overheads. We'll get to those in the next couple of slides. So now I've decided to promote my first microservice. Any reasons for this? I might want to scale something differently. So the problem with monoliths, if I have to scale one piece, I have to scale the whole thing. I might have reuse that I want. This is a touchy one. Depending on who you talk to, you're going to get different answers as to whether reuse is actually a legitimate reason for breaking out a microservice. There are many other reasons. How many people have read Building Microservices? Cool. So Sam Newman has a great book. I think there's 12 reasons why you'd break out a microservice, 10, 12, something like that. I am not going to cover those. I'm actually thinking about a second talk that would cover those. You'll have to stay tuned. Maybe I can get it ready for next year's conference and come back and tell you all about it. So here's what I've got. I've got an application, the big blue box, and I've got a couple of components that are talking to each other. Where I'm going now is this. I have two applications talking across a network to each other. The greatest thing about this component thing is when I break out email, the steps I have to take are build new application, write new controller layer, communication layer to the outside world, and slot in component. That's it. I build a new app, I just change the dependencies, and away I go. I now have a problem, though, because I'm talking over a network. So I've got a big cost. The first one is, because I was in process before, I didn't have to worry about dispatching of messages. That happened automatically by the language. Now I need to know where that second service is on the network. I also need to know possibly how many of them there are, how I'm going to route traffic to them, how I'm going to load balance them. All of this stuff pops up when you break out your first microservice. I always have network communication problems now. So everybody know the CAP theorem? When you do this, it becomes the CA theorem. Pick a C or pick an A. Because I now will have network partitions. That's just a thing. I may have VMs that disappear magically on Amazon. Who knows? So those are my two new costs that I've incurred by doing this. So I now need to mitigate those costs. The first thing I'm going to do is service discovery. I want a phone book so that when billing needs to know where email is, I have a layer of abstraction between those. And every layer of abstraction I add adds an additional cost. That's the cost I'm dealing with right now. I want to mitigate that. So I have this. So not only do I have two more network partitions that could happen, but I also have a third application to run. A third application that adds 0 business value. I have now simply added overhead to my system. The nice thing, though, so I've added the overhead. I got to monitor that thing. So if you're not monitoring your microservices, I would suggest you do that. But I now get this increased flexibility. So I can scale email independently. And the billing app doesn't really know anything about that. It's service discovery's job to take care of that. The next thing I need to do is deal with partition tolerance, because it will happen. So what I want to do is prevent this. I don't want the network to fail here and then have everything come crashing down around my head. I want this thing to be well behaved. I now have a distributed system. Welcome to having a new puppy. You have to teach it not to pee in the house. You have to teach it all kinds of things. And this is one of them, is this network partition problem. So I now have this. I have a fourth application, 2 more network calls. So these network calls are billing, asking, hey, is email okay? Am I allowed to call email? Because the last thing you want is one service hammering another service when it's like treading water trying to keep up. Because that's what causes the whole system to fail. At Netflix, I've heard the story that email is their recommendation service. So you have this service that they have trouble keeping up. I've heard stories. If you note it to be false, I'll stop using it. Just come let me know. You know how this goes. Old wives' tales in technology. But what I do now is I create this layer such that I know if email is working. If email is working, I can just go ahead and call through. If email fails, I am alerted to that fact and given the option of a default method to be called. So I now have a fallback. So all you functional programmers out there, the whole optional pattern, this is it. This is the maybe monad in distributed systems. I just made that up. You can all use that. All I want is attribution. It literally says, if okay, do this thing. If that breaks, call this other thing. It forces me to think about my fallback methods. So my users at the other end don't get this 400 or 505 that comes back. I'm sorry I couldn't complete your request. At Netflix, it's the, hey, here are 10 movies I think you might like, but they're not from your queue. They're just this canned 10 top movies that Netflix gives you. So that's what this does. It prevents me from this thing falling over, and then my client getting sad panda. But now I have 50% of my applications are non-business value adding. So there's the cost. So I've got more applications to run and monitor. If you're running Cloud Foundry, this becomes a little less of a cost because I can just push applications like nobody's business. Really easy. If you're waiting 6 months to stand up a server to run Circuit Breaker, now there's a little bit more cost there. I have an increased resiliency of the system because the network will fail. And I've got increased visibility of the system as a whole. So as part of this circuit breaker pattern, you want to do some monitoring that you can see what circuits are open and closed. Everybody familiar with circuit breakers in your house? You shut them off so you don't electrocute yourself and you like changing lights and things like that. If one of these things is open, you want to know because you want to get it fixed quickly. So the one that we use is Hystrix from Netflix. It's got a big dashboard, and I can see very clearly what services are up, what services are down, and things like that. So that's it. So I now have my first microservice. I have 2 apps to support it. I can continue to break out microservices. I can just keep going. I've already paid a lot of upfront costs, so I can now start to amortize the cost of that over more of my microservices. I can change up the communication interface pretty easily, because if I change to like a RabbitMQ queue or messaging, I just change the application. The domain knows nothing about how it's getting its information. Or I can do nothing. The choice is really up to you as to what the next step is based on your constraints. So some resources. This didn't just pop magically out of my head like Athena. So I wrote some stuff about application structure. Those 2 pictures of the Rails versus Spring App came from that blog post. The App Continuum by Mike Beranek. It's a whole long blog post with a bunch of code that leads you through the steps so you can actually see how this goes down. The video from Simon Brown is awesome. Highly recommend. He's got a bunch of good videos. Sam's book, Building Microservices, highly recommended. Very even-handed in this world. He presents a lot of things and says, here, you make the decision. It's not this, you will do this, you should do this. It's a little frustrating, though, because you're like, I just want the answer. What do I do? What is step 4? What is the next decision tree I make? Unfortunately, we don't get decision trees anymore. They're really hard to come up with. 1, because it's a hard problem. And 2, we're very early on in this evolution of this architecture. So we just don't know what those decision trees look like yet. As are many things, Martin Fowler's kind of my go-to person for microservices stuff. He's doing a lot of cool work of bringing other people in to write on his blog. So I minimize my communication channels by just going to his blog and seeing what's going on. You might have your own. And then as far as Java and Spring go, there's a project called Spring Cloud, which takes all of the Netflix open source, wraps it in a really nice Spring Boot wrapper, and makes you do really cool things. So for example, in Spring Cloud, in order to stand up a Eureka server, I think it's 12 lines of Java code and 1 annotation, and you're done. It's that easy. Hystrix is the same way. I think it's same 12 lines of code and a different annotation. So some really cool stuff going on in the Java space around this. And that's all I have. Is there maybe questions for me? No time. Sweet. All right, so if you have questions, come find me, and we'll go from there. So thank you so very much.